In this video, we're going to talk about graphing polynomial functions in factored form. In this course, we will only be graphing the polynomial functions from factored form. So, the factors of a function give us the zeros of the graph or the x-intercepts. If you remember back to quadratics, when we wanted to solve the function, we would factor it down into two factors and find the roots of those factors by setting each factor equal to 0 and then solving. And so here I see that I have roots at 1 and -3. So what that means for the graph is I'm going to cross the x-axis, or the graph is going to cross the x-axis at -3 and 1. So this is where we use the degree and what we know about the end behavior to fill in the rest of the graph. So we know here that the degree is 2 because since there is no exponent, it's an assumed 1. And in factored form, when we try to find the degree, we add up our exponents, giving us the degree is 2. Notice out in front there is not a negative, so it's a positive function. And since the degree is 2, it's a positive even function, meaning it's going to open upward. So since each of these factors have the exponent 1, I'm going to cross through them. So I cross through the -3 and come back through the 1, like our typical quadratic or parabola with the roots -3 and 1. Now, these exponents here are referred to as the multiplicity of the root. And multiplicity tells us what exactly happens at the zeros. So here, since my multiplicity was 1 for each of these factors, it told me that I was going to cross through the roots -3 and 1. Once again, the multiplicity refers to the factor's exponent. So let's look at this example. Y equals x minus 1 squared times x plus 3. I have a multiplicity on the x equals 1 factor, so this factor here of 2, and I have a multiplicity of this factor of 1, and that's my root -3. Now notice when I have a multiplicity of 1, that's considered a linear, so that's where we would just cross through the root. When the multiplicity is 2, I have a mini parabola where it looks like I'm bouncing off of the roots, kind of like a double root. And then when I have a 3 multiplicity, it's going to look like a mini cubic function where the function changes directions. So we begin graphing by graphing our roots, which we got from our factored form, and then looking at the leading coefficient and degree. My degree here, I add my exponents, is 3. The leading coefficient is positive, so it is a positive odd function, meaning it's going to look like a typical cubic where it rises from on the left and continues, and the directions are different. It has different directions. So we know that at -3, since the multiplicity is 1, I'm going to go straight through -3. But when I come back down to hit the 1 root, the multiplicity 2 says I'm going to have a mini parabola, so I'm going to bounce off, and that's going to give me the other direction for the end behavior. So this function here is going to cross through the -3 and then bounce back from the root 1, giving me the sketch of this function. And once again, it is called graphing polynomial functions, but what we are doing by drawing the roots and sketching end behavior is really sketching. So let's look at another example. Y equals x minus 1 cubed times x plus 3 squared. Notice here the x minus 1 has a multiplicity of 3 and x plus 3 has a multiplicity of 2. So what that tells me is at negative 3 I'm going to have a mini parabola or a double root where I bounce off of the root, and then for the root x equals 1 it's going to be a cubic, so it will change directions. So once again I need to identify my degree, which I add my exponents, and I have 5. I look to see if a negative is out in front. It is not, so I have a positive odd function. Once again, a typical odd function where I'm rising or falling from the left and then going to have a different direction for my end behavior. So as I'm coming up to this negative 3 root, notice negative 3, it's a double root or a mini parabola, so I'm bouncing off of it. And then when I go back up to hit the 1, I change directions. And notice when I change directions, it looks as if I'm increasing and then I switch. So notice that change in direction. When you're graphing with a multiplicity of 3, you want to make sure you emphasize that change in direction. So let's look at another example. Y equals negative x minus 1 squared times x plus 3. Once again, my roots here are negative 3 and 1. Each root now has a multiplicity of 2. So at each of these roots, I will have a mini parabola or a double root. I identify my degree, which I add the exponents and I get 4. Well, notice now I have a negative. So now I have a negative even function, which based off of a previous video we know is our function is going to open in the same direction, but since it's negative, it's going to open downward. So as I am coming up from the left, when I get to the negative 3, I bounce back, go back up to the 1 root, and once again bounce back because the multiplicity is 2, and that allows me to have a downward facing or opening downward polynomial function. The final example is where we're given a graph of a function and we have to determine the factored equation. So notice here, the first thing I notice are that my roots are negative 4 and 2, which translates to factors of x plus 4 and x minus 2. Notice if I were to solve x plus 4 equal to 0 for x, I would get negative 4. It's the opposite of the root. And so from these factors, I have to add the multiplicity. Which, as I see at 4, at the root negative 4, I have a mini parabola where I'm bouncing back. So my multiplicity is 2. And then at the 2 root, I notice that I'm just crossing straight through, so my multiplicity is 1. You can write 1 or leave it. But also notice, since this is an odd function, since the end behavior is in different directions, I am falling on the left, or I'm coming in from the left, which is not typical of a positive odd function. So it shows that there's a reflection of the x-axis, which tells me that there needs to be a negative out in front. And this is how we would write the factored form of this polynomial function. At this point, we're just sketching and not worrying about these maximum values. We're just looking at where we're crossing the x-axis. Thanks for watching.